Okay, John Marsh here, continuing my example problems for homework 3, Forouzan 23 and 31. Let's start with 23. So 23 and 31 are what I'm doing on this video. And starting with number 23, it says that a file contains 2 million bytes. How long does it take to download this file using a 56 kilobit per second channel, which is your old 56K modem, versus a 1 megabit per second channel? Okay, so it's going to, right away we can say, look, it's going to take a lot less time on the 1 megabyte per second channel because it's a much faster channel. Let's do the calculation. We have a 2 million byte, so n, I'm going to say, number of bits is 2 times 10 to the 6th bytes. Immediately, I'm going to, number one, put that in exponential notation, 2 million bytes, and I'm going to write 8 bits per byte. Okay, and I'm going to immediately convert this into 16 million bits. 16 times 10 to the 6th, 2 times 8 is 16, and the E6 stays. So that's the first thing I'll do. And then I'll say that for part A, the bit rate is 56 kilobits per second. And for part B, the bit rate is 1 megabit per second. Okay? And so the question is, T download is equal to what? And this is very straightforward. N is the number of bits, and I can say that the bit rate is the number of bits divided by the time it takes to send or download that number of bits. Okay, and I can solve this equation for T download, and this makes sense because it's bits in the numerator and seconds in the denominator. Bits per second is the rate. So T download is N over the bit rate. And this makes sense because T download is proportional to the number of bits. So you double the number of bits, you double the download time, but it's inversely proportional to the rate. You cut the rate, the data rate, in half, and it's going to take you twice as long to download. A higher data rate gives you a lower download time. So for part A, we have T download is equal to N over RB from part A, which is 16e to the 6th. And the bit rate is 56 kbps, or 16e6 over 56e3. Let's see if I can do this. Apparently, I don't have the numbers here. 16e6, 16 times 10 to the 6th, divided by 56e3. And I get 285.7 seconds. Okay? Now for the higher bit rate, T download is N over RB, which is 16e6 over, now the rate is 1 megabit, 1e6. This one you don't even need the calculator for, it's just 16 seconds. So it's 285 seconds versus 16 seconds. Okay? So that's exactly what we expected, a lot less time to download. Okay, let's finish this up and do 3.31. 3.31 says, what is the length of a bit on the channel with the propagation speed of 2 times 10 to the 8 meters per second if the channel bandwidth is, and again we've got a bit rate here and he calls it bandwidth. That's okay, I'm going to go ahead and label it as an R. So 1 megabit, 10 megabits, 100 megabits. And right out of the gate we should think of this and imagine this, that if the bit rate is slow, You know the speed of light is very fast. If it takes a long time, like 1 microsecond to send out a bit, it's going to move pretty far in a microsecond. But if we're at 10 times that bit rate, or 100 times that bit rate, it's going to move less distance, okay, in that bit period. So let's do the calculation. So we know the velocity we know the velocity is given as 2 times 10 to the 8th meters per second, and we have, for part A, the bit rate is 1 megabit per second. B, the bit rate is 10 megabits per second, and C, the bit rate is 100 megabits per second. Okay, and the question is, LB being the length of 1 bit is equal to what? Okay, this is going to be straightforward. Oh, I'm sorry. Well, you didn't need to see me write all that down. You heard me say it. I'm going to use exactly the same. Well, what I'm going to use is distance is velocity times time. And so I'm going to say that the length of 1 bit is equal to the velocity times the period for 1 bit. Okay, so I use the general relation, distance is velocity times time, and I said, well, in the time of 1 bit period, our wave is going to move the length of 1 bit. Okay, so this is length of the bit on the wire. Okay, and TB is 1 over RB, so this is V over RB. And I can write this down then in all 3 cases as 2e to the 8th over 1e to the 6th. Let's see, 1 megabit is 1e6. This is 10e6, and this is 100e6. 2 times 10 to the 8 over 1e6, 2 divided by 1 is 2, and I get 8 zeros in the numerator and 6 in the denominator, so I'm left with 2 left. So 200 meters. If I have 2e to the 8th over 10e to the 6th, it's just 1/10 of the previous answer, or 20 meters. And finally, 2e to the 8th over 100e to the 6th is 100th the original answer, or 2 meters. Okay, so that should finish up homework 3's example problems. Hope that helps.